Alright, here we have a Newton's second law reassessment. In this problem, we have the Dukes. They're driving along through Hazard County, and all of a sudden, a sinkhole appears in the road 18 meters away. And we're trying to figure out if they'll be able to stop in time, if they'll have enough stopping distance to avoid falling in there. So we take our free body diagram of the car, and we have the normal force going in the positive y, the mass of the car and the gravity going in the negative y, and then we have the friction force in the negative x direction. Alright, so the whole idea behind Newton's second law is force equals mass times acceleration. So here we have the forces in the y direction, which is the normal force, and their mass and gravity, and which is equal to 0. So normal force equals mass times gravity. And in the x direction, we have the negative friction equals mass times acceleration, which is this term here equals mass times acceleration, same thing. Alright, and then you have the mass and the gravity. So you have 0.67 equals, negative 0.67, I'll get this right eventually, times 9.8 meters per second squared gives you their acceleration. And their acceleration is negative 6.6 meters per second squared. Alright, so we need to figure out if they're going to have enough distance to stop. And so we take our kinematic equation here. Velocity squared equals the velocity initial plus 2a times total distance or displacement. So we have 0 equals 16 meters per second squared plus 2 negative 6.6 meters per second squared delta x, which gives you negative 256 meters squared per second squared equals negative 13.2 meters per second squared. And when you divide both sides by negative 13.2 meters per second squared, your units cancel out, so you're just left with meters, and which leaves you with 19 meters. And they only had 18 meters of road left, so unfortunately for them, they're going to be falling into the sinkhole.